sides of our equation in order to help us do some word problems. So notice that the name of the lesson is Adding Polynomials to Transform Equations, and which this is a continuation of what we were doing yesterday. And if you look there in the book on page 134 at the bottom of the page, there are these word problems. So when I give you your assignment for next time, it will be those word problems that begin at the bottom of that page and continue on the next page, all right? Well, again, let's look at a few examples of word problems. And right here on the board, I have written an example in which we are asked to find a number such that 7 times the number is 32 more than 3 times the number. All right? So you think about that for a few minutes, and you say to yourself, well, let's introduce a variable, and let's let x be what? And David says, a number, all right? A number, N-U-M-B-E-R. Let x be a number, all right? Now, find a number such as 7 times that number, and give me an expression for that. Who now can write the equation? Who thinks he can write the equation? Huh?
7x
7 times that number is equal to
3x plus 32.
It says 3 times that number, 32 more than 3 times that number. Is that right? Which is exactly what Todd said. And you look at this and you say, well, this is a pretty easy problem. I can do this without too much trouble. Now notice here we have the variable on both sides of our equation, and that was what we were doing in today's problems. And now let's go ahead and solve it. And everyone says what? We can do what to both sides? Ron says?
Take the 3 and subtract from each side.
Well, we're not subtracting the 3 from each side, but we're subtracting 3x. And give me a simpler sentence here.
4x equals 32.
4x equals 32, and of course a simpler sentence of this is
X equals 8.
x is equal to 8, all right? And since x is 8, now let's go back and see if we can't check. Remember our 5-step process as we do these word problems? And what then do we want to say? Find a number such that 7 times that number. Now 7 times that number is what? 32 more than 3 times that number. 32 more than 3 times that number. So on the left-hand side, we have a number of what? A number 56. And the question is this number equal to what? 24 plus 32. And everyone says yes. It checks. Therefore, we write a conclusion which says what? What do I want to write here, David?
The number is 8.
The number?
I mean, the number is 8.
The number is 8, all right? And let's indicate our steps. There's our first step. Our second step is to write the sentence. The third step is to solve that equation. The fourth step is to check it in terms of the original conditions of the problem. And our fifth step is to write a sentence, which is our conclusion. We've answered the question that was asked in the problem. Okay? Let's go on to our next example. Here we have a problem which it says, find an angle such that the measure of its supplement is 20 degrees less than 3 times the measure of its complement. So you think about that for a second and you say, all right, I ask you, what's the angle? And what are you going to say? What's the angle? Now, this is about the 3rd time that I've asked this question, and rather than you're thinking of a number, I don't want you to think of a number. When I ask you, what's the angle? Brenda says, x. All right, let's let x be the what? Number of degrees in the angle. Let me use this angle symbol again. All right? Well, if x is the number of degrees in the angle, how many degrees are there in its complement? In its complement. Chuck?
180.
Well, the complement of an angle, by definition, is that number which, when added to this angle, must be what? Chip says?
I was going to say 90 minus x.
All right, 90 minus x then is its complement. 90 minus x is the number of degrees in the complement, COMPL. Let me abbreviate in this fashion. What then is the number of degrees in the supplement of the angle? And Ken says?
180 minus x.
180 minus x is the number of degrees in the supplement. All right? Now notice we wrote all of this down to indicate what our variables are. Now let's go back to the original problem and see if we can't write a sentence. And what's it say? Such that the measure of its supplement, all right? Give me its supplement. And Steve says, Steve Bossy says, What's the supplement? Well, we've written it down here. Give me the supplement. And Chip says 180 minus x, all right? The measure of that supplement is, all right, and when we see the word is equal to 20 degrees less than, 20 degrees less than, all right, 3 times the measure of its complement. So what then are we going to write in here, Kirby?
3 times 90 minus
3 times, parentheses, 90 minus x. Is that right? All right, so Steve, the measure of its supplement is 20 degrees less than 3 times its complement. Brenda?
Shouldn't you add that 20?
I don't know. Let's check. Find an angle such the measure of its supplement is 20 degrees. The measure of its supplement is 20 degrees less than 3 times its complement. And in fact, I think, well, let's check the thing through. Let's actually work through our equation and then go back to the original conditions of the problem and see if indeed this will work. And if it doesn't, we'll come back and look at it with what? A plus sign in there. Let's see what happens, shall we? All right, and let's see. Now, who's going to write a simpler equation here? What then can we say? Ron says 180 minus x is equal to, well, 3 times 90 is 270 minus 3x minus 20. Is that right? All right, and let's see what we can do with this. Oh, here we have the opposite of x, and here we have a negative 3x, so let's decide to do what to both sides? Probably the easiest thing to do, Todd says, is add. All right, we can either add x, or perhaps it might be easier to end up with a positive value, a positive coefficient. Steve says add 3x. And if we were to add 3x, 3x plus a negative x is 2x, okay, on this side. And now, let's see, we have 270 minus 20 is what? There's 250, is that right? And we have here 180 on the left side, so what do we want to do to both sides here? And that is to subtract what? Subtract 180, is that right? And let's see now, that says that 2x is equal to what number? If I subtract 180 from 250, we get 70 degrees, 70, rather, the number 70, and then x is equal to 35. Well, let's check and see what happens. Brenda's not quite convinced of this equation. Now, if the number is 35, that's the angle itself, all right? 90 minus x is going to be what number? All right, this is the complement. 90 minus x is what? Well, 90 minus x, if x is 35, 90 minus x is what? 55, all right? And 180 minus x is going to be what number? 145, is that right? Okay, now let's check those 3 numbers in which the original problem says find an angle such that the measure of its supplement, all right, the supplement is 145, is what? 20 degrees less than what? 3 times its complement. Is that right? So let's see if this statement is true. And 3 times 55 is what number?
165.
That's what? 165 less 20 is equal to what? 145. Is it check?
Yes.
I think this checks with respect to the original equation, and I think then, let me write it right over here, therefore, what is our conclusion? The question asks, find the angle. So what then is our statement that we can write right in here? And Mary Lou says,
The angles are 55.
well, it just asks for the angle itself, so the angle is, and Jane says 35. So let's write the sentence which says what? The angle is what? Well, we're talking about a degree measure, so let's just indicate here what? The angle is 35 degrees, and we have this degree symbol that we use for degrees. Okay? Again, our 5-step procedure. The first is to identify our variables. The second is to write the equation, and the writing of the equation is, as I said yesterday and the day before, is going to be the most difficult thing that you're going to be able to have to come up with. The third idea then is to solve that equation. The fourth is to check, and the fifth then is to write your conclusion. Let's look at another example. A father who is 46 years old has a son who is 12 years old. In how many years will the son's age be 1/3 of the father's age? All right, so it asks, in how many years? And again, let me just ask you that question. In how many years will this happen? Will he be 1/3? Chip says, let's let X be that number of years. Let's let X be the number of years when the son is what? The son is what? 1/3 the father's age. Is that what the question asks for? All right. That's a long sentence for me to write in there. Well, what now can we say? The father is 46 years old now and the son is 12 years old now. In how many years will the son's age be 1/3 of the father's age? Who thinks he can come up with a sentence which will do this for us, which will take care of the conditions of this problem? Brenda?
12 plus X.
12 plus X. X years from now, if he's 12 now, and some number of years from now, he's going to be 12 plus X years of age. Good.
In parentheses, then, divided by 3.
Okay. And this number divided by 3
Equals 46 plus X.
46 plus X. All right. There might be another way that someone else might have thought of that perhaps is a literal interpretation of this problem up here, rather than thinking of it, well, is this what we want to say? Is this what we want to say? In how many years will the son's age, be 1/3 of the father's age? And I'm not sure that this equation will give it to us. Ron says
46 plus X should be divided by 3.
the 46 plus X should be divided by 3. Is that right? So I think what you wanted to say was 1/3 of the right-hand side, and 1/3 of that we can indicate by dividing it all by 3. Is that right? Well, our equation is a little bit, here, let me then put this on the same line. We have here 12 what? Plus X is equal to this expression. Now, for the first time, we have a number in the denominator in a problem, in a situation, in an equation. So we want to get rid of this number 3. And in order for us to get rid of it, since we are dividing, Kirby says,
Multiply by
let's
3.
multiply what? What? Both sides of our equation. Is that right? So we have to multiply this by 3, and we get 36 plus 3x. And remember, that's your distributive property, which says 3 times 12 plus 3 times x is this, okay? And of course, on the right-hand side, we have 46 plus x, all right, is equal to, now let's, what? I see an x here and 3x here, so what can we do to both sides? And David says,
Subtract the X from the
subtract the x, and that gives us 2x, is that right? And then let's, we look at 36 and 46. What can we do to both sides here? And Chuck says, subtract 36, and that gives us what? 10, and hence x then must be equal to 5. Now, let's go back to the original question. We have a number 5 here. Let's check it. And what then do we want to say? In how many years will this condition hold true? So what? We started out with the son being 12 years of age plus 5. The question is that 1/3 of 46 plus 5? And let's see, 12 plus 5 is 17, and 46 plus 5 is
51.
And is 1/3 of 51 17?
Yep.
Yep. And everyone says yes. We'll check it. Therefore, our conclusion is what? The conditions will hold true 5 years from now, or whatever we want to write here. The son will be 1/3 the father's age. The son's age will be 1/3 the father's age in what? In 5 years. All right. Perhaps it's longer to write the sentence than it is to solve it. Again, our 5-step procedure in which we want to identify our variable, write the equation, solve that equation, make our check, and finally write our conclusion. Now, I can't emphasize this enough, and I hope that you are doing this when you do your problem. All right? Let's look at another example. In this case, we have the surface area S of a rectangular solid with length L, width W, and height H is given by this formula. S equals twice LW plus WH plus LH. Now it says express L in terms of W, H, and S. So you look in here and we see an L here and an L here. We want to express that L in terms of everything else. So we say, all right, let's just write our equation down. Twice LW plus WH plus LH. And we're interested in L. All right? Well, the first thing you say is, I don't like this 2 here. Since we are multiplying by 2, what then can we do, Steve says? Divide both sides by 2. And that is what? S over 2 is equal to LW plus WH plus LH. Is that right? So you look at these 3 terms on the right-hand side and you say, well, this term here does not contain an L, so we can get rid of it. And in order for us to get rid of it, what are we doing here? We're adding. We want to undo that addition. Todd says subtract it. All right, let's subtract it. Now there's still our S over 2 minus WH equals LW plus LH. Now I look at this, and there's one idea, one of our basic properties that should strike you. And what is that? One word. Brenda says distributed. All right, now on the right-hand side, there's L times W plus H. And we still have on the left side, S over 2 minus WH. All right? Now, we have taken this number L, using our distributive property, all right, out, in which we now have the product of 2 terms, of 2 factors here. And now we have W plus H in the way, which we don't want, so how do we undo that? Since we're multiplying here, Ron says, divide both sides by what? Not by W and H. I'm not sure I know what you mean by that. Todd says
By W plus H.
by W plus H, okay? Now if we divide the right-hand side by W plus H, that gives us L, and that's exactly what we want. So let's then divide the left side by the same number, and this is, perhaps I should make that a bigger letter S, since it's a capital S divided by 2, minus WH, all over W plus H. All right? Now that expression, well, let's use our symmetric property and write L then is equal to S over 2 minus WH all over W plus H. Now this expression looks a little messy, but indeed we ended up with L in terms of S, W, and H. And that's probably, we could do perhaps a little bit more with that, but for now I think that's probably the best way for us to look at it. Well, let's do one more step there. And this involves a little bit of arithmetic, which perhaps you'll have to recall from your work in 7th and 8th grade. I see this number 2 here, which I don't want. And so another name for the number 1 that I may write on the right-hand side is 2 over 2. Is that right? 2 divided by 2. Now, if I use my distributive property, twice S over 2 is what? Twice S over 2 is S minus twice WH is 2WH divided by, and now I still have twice. Now let's indicate that as just leave that factor 2 times W plus H, and there's a simpler name for this expression. So you may take your choice, all right? Well, I think that's all that we need to do for today, so let me give you your assignment for next time, in which I'm going to ask you, let me see, I think I can write it over here, in which I'm going to ask you to, this will be a